Off the southeastern coast of Africa lies the island of Madagascar. You may know Madagascar for its wild-eyed lemurs, but it's also home to one of the world's most colorful amphibians, the Mantella poison frog. Poison frogs aren't born poisonous, but rather they're proof of the old saying, you are what you eat. Their toxins come from something in their diet, which is largely ants, millipedes, and mites. But which of those insects is it exactly? And will a collapse of insect diversity threaten the frog's ability to survive? Meet herpetologist and National Geographic grantee, Valerie C. Clark.
Voila. This is Mantella betsilio, a very widespread Malagasy poison frog. It occurs throughout the country. This appears to be a gravid female. How do I know? Because it's just very, very fat, and this is the season for love.
For each site, Clark and her team use GPS data to log the frog's location and other useful information.
We're right at sea level.
They also need to collect as many insects as possible to try to track down exactly what these frogs are eating.
We use what's called the mini Winkler system to get an idea of the local arthropod or insect diversity with a focus on ants. And what we do is we chop up and sift leaf litter, then we put it into a mesh bag. We hang the mesh bag inside of a nice slick nylon bag with a little plastic bag at the bottom with alcohol in it. As the soil dries out inside of this mesh bag, the insects leave it to try to find moisture soil and fall out and become our samples. They're quick little buggers.
How do you sample the toxins in a frog's skin? Well, there are a couple of methods.
On this trip, I've just been taking alcohol on like a little tissue and wiping their backs to get some additional samples to look at variability in individual poison frogs at different sites.
But Clark also has another way of testing for these toxins in the field, what she calls a quick lick taste test.
Let's see. Oh, it's definitely bitter.
Bitterness equals toxic. The reason Clark doesn't keel over from the poison is because Mantella are only mildly toxic to humans. They are brightly colored. That's to serve as a warning to potential predators to stay away. These alkaloid chemicals in the frog's skin that may be harmful to other creatures could be helpful to humans. They might hold the key to new medicines, such as pain relievers and heart disease-fighting drugs.
By sampling frogs for their toxic chemicals, we're effectively taking a shortcut to the many, many chemicals that exist in countless insects in the rainforest. I really want poison frogs to be viewed by the general public in the same way that Madagascar's charismatic chameleons and lemurs are. I believe that they're really, really important, not only because they lead us to drugs and potential green pesticides, but also just because they're gorgeous.
Back in the village, the results look promising.
Oh, here we go. Here's Rhinotus purpureus, a little millipede that has several alkaloids in common with Mantella poison frogs. I'm very excited about these samples. This is certainly making up the great portion of the Mantella diet and has great potential to end up being some of the sources of their chemicals.
In order for the frog's toxins to be effective, they need a variety of prey to dine on. The bigger the forest, the more insects to choose from.
The frogs have more of these different chemicals in undisturbed primary rainforest, which is just another reason to show that as we start to disturb rainforest and cut them down, there are less toxic chemicals that have the potential for drug development. So the more primary forest that we have, the better chance we have of finding new drug leads.
Near the end of her journey, Clark has collected 500 tubes of insects. These are dietary footprints that could lead her to some sources of the frog's toxins.
I believe that understanding factors that affect Mantella distribution is critical for designing good conservation strategies.
Clearly, she has a lot of lab work ahead of her, but already she's coming to one conclusion. In order to save the poison frogs of Madagascar, people will have to save the habitat with its diversity of insects.
Sponsored by National Geographic Mission Programs, taking science and exploration into the new millennium.